Everything good, Faisal?
Everything excellent.
Hey. I don't have the pendulum questions there. Does someone have them open? Oh, well, I can get them here now. DIFC, physics. Do I have enough power for 10 minutes? I do. Right, mechanics, pendulum. What's so funny? What? No, seriously, what's so funny? Are you low on blood sugar? I mean, what's wrong?
No, you're nothing more than your height.
Maybe you're different, I don't know. Okay. Pendulum has a length of 0.82.
If you really want to know, I'll tell you after the class.
Oh, it's dirty, isn't it? And the amplitude is 35 millimeters, so it's like this. Right, let's see how quick we can do these. A, what's the time? Time is 2 pi root L over G. Well, what did you get for that?
1.82.
1.82 seconds. Okay. B, what is the maximum velocity? So you have the formula V equals omega square root A squared minus X squared. The maximum the velocity could be is A omega. And that happens when? When
X is A.
X is 0. Yes, indeed. So
A.
no, then it's 0 velocity, because A minus A is 0. Mind blown. Right, so what is V max here when you multiply A by omega? Well, do we know the omega? 0.035. Omega is 2 pi over T. So, what?
Should I leave? Power you have.
What did you get? 0.293?
No. 0.121.
0.035 times 2 times pi divided by, oh sorry, I put in the wrong time, 1.82. This 0.121 meters per second. C.
Can I write only the formula V max equal
A omega? Yes, you can. When will this motion occur? I've already answered that. When x is 0, which is at the lowest point. D. What is the maximum acceleration? Acceleration equals, I don't care about the minus, I just want the number. Omega squared s. So what is the biggest this can be? Omega squared a. So that's 2 pi over t squared times a. What's that?
0.5419.
Meters per second squared. E. When does this occur, maximum acceleration? Well, when it's x is equal to a, which, when is x equal to a in the pendulum's motion? At the ends, yeah. So this is at the ends. Okay, F. Sketch the graph. Well, we know what the graph looks like. This, which one is this? The one I just drew, kinetic or potential? Potential. And then this one here, kinetic. And then this one here, total. G. What is the total energy if the mass is this? So the total energy is equal to the kinetic plus the potential. However, watch this trick. The energy doesn't change. So we should pick a point in the motion that's most convenient. We shall pick the point when it's lowest or highest. I'll go with lowest. When it's at its lowest point, does it have kinetic energy? Yes, it's still moving at its lowest point. It doesn't have potential energy. So it just has kinetic energy, which is a half mv squared. If only we knew the maximum velocity. But wait a second, we do. So that's a half, what's the mass? 0.0045, was it? Yeah. And the number here is 0.121 squared. What did you get?
No.
What do you mean no?
0.045. It's minus 3.
Yeah, it's 1 0.
45 times 10 to the minus
0.04.
0.045.
0.
Yeah, bro.
Right, I have too many zeros, huh?
Yeah.
I can easily fix that. Alright, so what do we get here?
3.29 multiplied minus 5.
Minus 4, and the unit? Joules. Okay. H. What is the length if the frequency is 0.75? So if you change the length and the frequency now 0.75, what's the new length? Okay, so frequency equals 0.75. That means the time equals 1 over 0.75, which equals 2 pi root L over G. How can I solve this equation? What should I do first? I should square everything. 1 over 0.75 squared equals 4 pi squared L over G. What's the thing I don't know here? L. So if I just rearrange this, I get L equals G over 4 pi squared, 1 over 0.75 squared. You made a mistake, or you have the answer. What's your answer? 0.42 meters. Thank you. HI. What would happen to the time if the bob was replaced by one of the same shape but twice as dense? Like more mass. Nothing. What would happen to the time if the pendulum, if the amplitude was halved? If you make the amplitude smaller, what would happen to the time?
Nothing.
Exactly. What letter comes after I, J? Nothing for both.
What is J? What is